All right, we have this question here, question 2.2. Question 2.2 says we need to calculate the value of the sum of 100 minus 3k when k starts from 1 to 50. Okay, so this is how we can solve the problem. We can see that we can find the first term in this question, A, the first term, which is actually A. Sometimes the first term is, we know it's T1, but in sequence and series we write it as A. It can be found when we sub in the value of 1 on the expression inside the sigma notation. So A will be equal to 100 minus 3 k, but k is 1 now because A is the first term. So we'll sub the value of 1, this very first value there, and then we got the value of A, which is equal to 97. Okay, and we can also find the last term, Tn. Okay, but it is denoted as L, L in the sequence and series. So we can do 100 minus 3 k, and then we sub the value of k, which is the last term in the series, which is the 50th term. So we're going to sub 50 over here, 50, and then that's going to be 100 minus 150, which makes L equal to negative 50. So that L, negative 50, the last term. I use that because we have a formula that says the sum of Sn equal to n over 2 times A plus L, the first and the last term. So Sn will be equal to n, how many terms? There are 50 terms. So we have 50 over 2, open brackets, A, the first term, which is 97. Okay, going to move this way, and then plus negative 50. Okay, just make it square bracket. And now Sn will be then 25 times 47, and which is equal to 1175. Sn equal to 1175. Yes, we can also solve the same problem if we use the other formula for Sn. We also do know that Sn is given by n over 2, open square bracket, 2a plus n minus 1 times d. Okay. Okay, this formula is used in all the cases. Okay. But this other formula is used only when the first and the last term are given. Okay, I'll write like this. This formula, this one. Let me show it like this. I'll write the comment here. Use only when the first and the last terms are given. This one can be used in all the cases. Okay, so now in this situation, what we can do, we do know the number of the term. Okay, and there are 50 terms. As we can see here, there are 50 terms because the sum goes from 1 to 50. How do I know 50 terms? Because I do 50 minus 1 plus 1, that's the formula. Okay, all right, maybe let me start with writing the number of the term. The formula will be given by n minus 1 plus 1, always. plus 1. So n will be obviously 50, okay? Because if you do 50 minus 1 is 49, plus 1 is 50. So there are 50 terms. Now we can find what is A. A is the first term. So T1 here will be A, which is equal to 100 minus 3 times 1. And we got that A equal to 97, right? 97. And then D, which is the constant difference. D, we can find D by looking at the coefficients of K, of the variable. So the -3 that we see over here, -3 is D. So we can find D. We say D is equal to -3. Therefore, Sn will be then n over 2, so 50 over 2 times 2a plus n minus 1 times d. Okay, n, we know the value of n, minus 1 times d. So a is 97, n is 50, and then d is -3. Now, if we substitute, if we calculate this, okay, just gonna draw a line over here, and then we'll have Sn equal to 25 times what? 2 times 97 is 194, and then minus -3 times 49 will be 49 times -3. This is equal to -147, and then we end up with 25 times 47, and this is equal to 1175. That's it. And notice that it's the same, this answer and this answer and that one are same. Thank you.